So welcome to the fifth RIS session, is it correct?
I don't know, every
Or
month it happens.
And because we had some technical delays in the beginning, let's jump right to Claudio, so please go ahead.
Yes, thank you very much, Kalle and Matti. That's great to be here and organize this event. So I guess many of you know me. If not, I'm Claudio Roncoli. I'm assistant professor in transportation engineering at Aalto. And I'm kind of leading the smart mobility team in the Finest Twins Center of Excellence. So my role today was essentially to organize this session and try to cover a few of the elements that we are actually treating within the smart mobility stream of these activities. So as we said, so this is about data. So we are I try to cover the whole, in a sense, spectrum of this data. So when we talk about mobility, there are of course a lot of issues in our work. So there is data that is easy to collect, maybe, or easier to collect, a bit more difficult to be used. There is a lot of data available out there, but we don't really know how to use it or what's the wisest way to use it. And of course, there is always issues of privacy, of sharing data, of who can get data for what. So what we are going to see today, we have several activities now. This is just a couple of those that are going on, or they are possibly linked to Finest Twins now or in the near future. So the first presenter is going to be Serio Agriesti. He's working on modeling mostly. So of course, when one asks why modeling, why do we need modeling? And in this case, we are talking mostly about mathematical modeling. This is about trying to represent in some way what we know and what we don't know as well. So that's what modeling can actually help us, is understanding what is going on. And in this case, we want to understand mobility of people, why people move, how people move. And these, of course, an interest point as such, but also when we think about future mobility and future mobility services, when we think about connectivity, automation, and all the other future issues. So we hope this model will be a starting point, I mean, for future activities in Tallinn as well. And of course, there is a point in here that there are models that exist already for Tallinn and for other cities, and then what we realize is that what we all know is that the more complex we want our model, the more accurate the model we want, the more features we want in the model, we also need more data. And then this data is not easy to gather, not easy to put together. And so that will be essentially Serio's presentation about his first efforts in these modeling activities. Model is not finished yet, but it will. And well, worth mentioning, we are planning to make all the results that is going to get as open as possible. So open access, so other people can play with this model, add things on the model, etc. Second presentation is going to be by Iisakki Kosonen, and here domain is a little bit different. In a sense, there we are talking about traffic management, and in particular, where we think about operation, real-time operation of traffic systems. And in here, we are running, is on the top of a project from the academic side that, well, we call it internally Smart Junction. And this is about actually a platform that is under development to collect and openly share traffic data. So we are installing sensors, detectors of various kinds in an area in Jätkäsaari in Helsinki, and we built a platform in sense to distribute this data, to make it openly available. And then the plan is, of course, to extend this to Helsinki, to other parts of again in this Jätkäsaari for now, but of course open to include this also in the Tallinn area if we have the possibility. And the third presentation, as mentioned earlier by Kalle, is about mobility launchpad, aside from Forum Virium, so Helsinki, and how actually these kind of initiatives can actually improve innovation in these areas. So I already said too much. I wanted to be much faster, and so that I leave the floor to the real presenters, or the one who really are going to give you a bit more details on the job, on their job. And yeah, so that's it from my side. I think I can directly leave the word to Serio, who can start with his presentation. Thank you.
Thank you, Claudio.
Thank you.
And Serio, you should also be co-host, so feel free to take the stage.
Thank you for the introduction and for the description, Professor. And can I ask you if you see the PowerPoint?
Yep, it's visible.
Okay, perfect.
So, yes, but not full screen. Okay, now it's full screen.
As was mentioned, this first presentation is about the development of the model that we're working on, and especially the agent-based one of the city of Tallinn. And I'm going to focus on the process of generating a synthetic population, focus on data requirement, early results, but also issues and steps that can be undertaken to make this kind of activity smoother, because this kind of models is quite new, so data are not always available. First, a couple of words about, well, the objective of our wider activities. As Professor Roncoli said, we are building a model per se, which is actually the result of integration of a traditional traffic model and an agent-based one, with the aim of exploiting it to answer some research question about automated driving with the city of Tallinn as case study. We are choosing to integrate those two models because the traditional traffic models focuses more on the supply, which means the amount of transport services that are available to satisfy the amount of travel, which is actually the demand that is generated by the population in a case study. So when we speak about supply, we speak about the transport network, public transport network, all the modes available, performance costs, while the demand is the amount of travel that is generated by the population. Why we're integrating the two softwares? Because traffic models do focus more on the supply, which means that the demand, that is usually the input, rarely is responsive to the actual performance, while the agent-based model do account for the performance of the supply while computing the demand, but they are more often than not mesoscoping in their analysis, which is not ideal when you speak about automated vehicles and their interaction, microscopic interaction with traditional vehicles. Once the model is ready, we hope to achieve the following. Having this interaction framed, we will be able to design fleet sizing that takes into account both the demand, so the market available, and the actual traffic that is generated, so the delays that actually impact the demand. This will reflect on the fleet sizing of a fleet of autonomous vehicles, and we will be able to make this kind of model a test bed for different prototypes, driving algorithms of autonomous vehicles, or even operational parameters such as headways. So the model can be indeed of interest for many stakeholders. This is about car makers, but framing the impact on congestion patterns within the whole city of a fleet which is as precise as possible, I think is really interesting also for municipalities, many stakeholders involved. In the end, this kind of analysis will result in impact assessment which is more precise, sounder, and on which an actual business case may be framed. But that's the general work. Why I introduced it? Because half of it is an agent-based model, and the inputs of agent-based models are really, really big data sets that include individuals, all the individuals in the case study. For the city of Tallinn, it will mean a data set of more than 400,000 people, individuals, with details about the structure of the population. So the societal and economic factors per each entry, the household structure, the spatial distribution, and the anchor points where are situated the workplaces or the education points, and the factors internal to each household that then impacts on modal share. So the number of vehicles owned, maybe related to the average income of the family member, and so on. It should be clear that this data set does not exist, and it should not, because privacy concerns would be incredible with such a data set. So how is it possible to actually build an agent-based model for the work that we have to do? The solution that can be already found in literature is the building of a synthetic population, which is a statistical equivalent of the real population, which means that the interaction between variables and the distributions are kept. But it is built starting from an original data set, which is way smaller and is based on the answers of existing people, so existing individual, anonymized accordingly. And this small data set is then, let's say, upscaled based on available margins, so distribution on totals for the city. The overall number of individuals, more than 400,000, but also the overall number of households, sorry. The interaction between average income and the owning of cars or other vehicles, all these relationships should be taken into account while building the synthetic population. The final result is a data set that indeed has more than 400,000 individuals, but they are not real ones. So obviously anonymization is still to be taken into account, but the privacy related issues should be overcome this way. And the presentation is about how to build this synthetic population. What are the data needed? In the case of Tallinn and our work, we started from travel diaries that were provided by Taltech, for which we are really grateful. They included more than 4,000 entries with details about the households, which are the one underlined, household structure, the residence sub-district, the number of children, the income per family member, and so on. And details about the individual, gender and age, the education level, the kind of occupation, and so on. An additional set of data in the travel diaries was distributions of some variables that were not into the data set as provided, but could be were related. For example, the distribution of car owned per household size, this kind of aggregated measures about the data set. This is one half of the input. The other half is the margins, the overall margins, meaning the overall number of individuals, overall number of households, there is spatial distribution, but also the distribution of gender and age in the population, or the kind of occupation, this kind of aggregates. And those were obtained for the city of Tallinn, both from the census and from the statistical yearbook of the city. Clearly, the underlining of the whole discussion is that those data are all public. Only once we weren't able to overcome the lack of data, we had to buy the data from MTAC. All the others were public to foster replicability and so on. The underlying principle behind the generation of the synthetic population is this replication and the random resampling, starting from the households, from the limited data set, travel diaries. These households were then picked and chosen accordingly and put into the basket of the synthetic population. The synthetic population, more than 400,000. And this picking happens by following, as I was saying, the distribution between variables and while satisfying the overall margin, so the overall number of individuals, overall number of households, and so on. But going to the process is a somewhat simplified version of the wider work of Tengvall et al., which is reported. The steps were as reported. We started by preparing the sample, so eliminating the outliners or noises from the original sample. Then we applied the iterative proportional fitting with about 2 variables that we deemed useful. There are obviously some choices from the modelers but concerning why, for what we wanted to use this data set. And I will go in detail later about the APF. Then the resampling, which was the picking of households to build the synthetic population. The adding of additional variables that were not present in the original sample, then the spatial allocation and the calibration of household size per average income. The first step, as I was saying, was applying the iterative proportional fitting, starting from the margins, so the aggregates that include the distributions of these 2 variables, and applying the algorithm, we were able to get the weights for each individual in the travel diaries, which represents how much they are representative of the actual distribution of gender per age in the population. Then the picking, the main step, which was the resampling to build the synthetic population, that takes into account both these EPF weights and also the distribution overall margins of the whole population. Then the additional variables, as I was saying, not all the details were present into the travel diaries for each individual. So we had to add following the conditional distribution. Variables such as the number of cars owned in each household or the licenses owned, depending on the household size and the average income per family member. Once that was accomplished, the population, which as for now was draft, we had 400,000 individuals in the synthetic dataset, was allocated specially. And as you can see, both the magnitude, how many individuals per each sub-district, and the trends are almost completely matching. And the last step was another calibration. The first calibration happens when you pick the households from the limited data set and you put it into the bigger basket. This was to get a somewhat perfect match between the household size and the spatial distribution in district. This again was a modeler choice. We wanted this distribution because it's going to be the most representative in our integration, but it depends case by case. This is only what can be done. Also, I'm not going too much into detail about each function and algorithm because they are available from the work of Temple et al. And also from the R programming package. Then the result is this synthetic population of the city of Tallinn dataset with more than 400,000 individuals. You can see here all the variables that were included with their degree of soundness. We have the one that were calibrated on the census or on the statistical yearbook that follow the trends and distribution of the population. We had the one that we assigned that follow the conditional probability that were present into the original travel diaries. We have the one that we could validate, which is the average income per family member, and for one that were not validated, but just are as representative as the travel diaries are of the real population. It is important to know these distinctions when you get your final results so that you know the worthiness and the soundness of each one of the variables obtained. Also, this data set is probably going to be made public in the following weeks because this is already finished and accomplished as a result. On the right here, you can see, well, the result, one of the results of our synthetic population process. This is the distribution that we achieved about average income per family member in each sub-district, with the red areas being the poorest one, the blue one being the richest one. Clearly, those are not real people, real individuals. So again, you overcome the privacy issue. This is the equivalent of having already aggregate statistics, but projected on your data sets of individuals. And then on the left, you see land use, because after achieving and obtaining the synthetic population, we needed to assign the anchor points like workplaces or the education and so on. This was accomplished by following the methodology of Jimmy et al. Adapted to our case study. First, we divided the case study through a grid 500 per 500 meters and classified each cell based on cadastral data. This classification that you can see on the slide was needed because based on this classification, we weighted each cell and based on this weight, we were able to assign residents in each cell. So a further degree of spatial disaggregation for our data set and also workplaces. For the residence assignment, the process is the one underlined in the slide. We started by building the grid. Then we assigned all the cells in each sub-district. We clustered them by sub-districts so that then their relative weight compared to all the other cells in the same sub-district could be calculated. This was for residents. So, for example, the high residential cells had an higher weight, and this was translated into the probability of having each singular individual with actually households, because households are assigned together, each singular households to a specified cell. And in the end, we obtained the assignment of our synthetic population in the city of Tallinn and in our case study. Again, without actually having data about the addresses and so on. The further step was assigning education. Here, depending on the kind of educational institution we are speaking of, at different sources of data. For example, basic and upper education, we had both the distribution between district of residence and district of education, meaning we knew the flows between districts for education-related travels, and also number about the attendance to each institution and the school addresses. While, for example, for kindergarten, the data about the distribution among districts was lacking, which prompted some hypotheses on our side, because those data, there are still some limited privacy issue in this process, obviously, and for kindergarten, this was one. But to detail the process for the basic and upper education, we started defining the probability for each individual in an eligible age range in each district, the probability of attending school in their own district or another district. And once that had been accomplished, only then a gravitational model was applied to define the probability of attending in a specific cell. In this slide, you can see the cell in red, which is the cell where the institution is located. And you have the number of people attending in this specific cell from all the other districts and their own district. This allows us to reproduce the distribution that are actually recorded and then do a last mile assignment, and only that is based on the gravitational model, limiting the noise that is added in this way. I want also to summarize, and I think this is one of the most important takeout of this PowerPoint, the process, but with a focus on the data required and the data that are not yet available, and the underlying reason why it's so. So for the generation of synthetic population, as we were saying, having a travel survey or a small data set with real people and margins. Then for the validation process, and this is one of the main issues that still remain for the generation of synthetic population. We had, for example, the income patterns from the municipality, but many other data that could be exploited and make the dataset sounder were not available. For example, the data from the motorization about car ownership were not available, so we had to resort to data from the travel diaries, which may be representative, but not as much as the official one. Then, for example, other things that are lacking are household sizes per sub-district, higher degree of spatial disaggregation, or occupation statistics. Here, it's not that these data were lacking, but this data followed a different classification than the one that we used for the assignment of workplaces that I didn't detail for reasons of time. The one that we used is the one from MTAC, and this is an issue of compatibility between datasets. The assignment of residence was probably the less critical one, meaning that the cadastral data allowed us to weight the residence cells. The assignment of education had different degree of challenges depending on the kind of education. As I was saying, the basic and upper education had almost all the data that we needed, but for kindergarten, that was not the case. And we had to introduce some hypotheses and thus some noise, which is why it's important to have data for validation. In our case, for example, even only the average distance for education-related travel will go a long way in allowing us to strengthen the model. But these data, again, are not publicly available or don't seem to be. So also traffic counts will be really valuable since we are going to assign the resulting traffic flow, but again, not public. Assignment of workplaces, I'm not detailing it, but it's important to say that this is the only step in the process that needed the purchase of data, because data about the number of workers per each district, for example, and the field of work, or the number of firms per each district and the field of work were not available. So we needed to purchase them, which is not a budgetary issue. They are not incredibly costly data, but it is an issue both about timing, but mostly about planning, not knowing which dataset you will have in the end, what are the characteristics, the kind of classification and the degree of precision of the information really dampens the planning at the beginning when you are building the model, at least conceptually. Other data that are somehow lacking are commuter data, especially towards Finland. And from Finland, there is only an aggregate at city level, publicly available, which is not really useful. At least at district level will be more useful. And again, validation data, the average commuting distance, at least per district. We know that it was registered in the Labor Survey of 2012, but it is not available if it is available only at city level. And knowing that the average commuting time in Tallinn is 30 minutes doesn't really help in validating the model. The main takeaway of these slides should be that validation is still an issue for these activities, but is not one that is caused by privacy issue. All the data on the right could be patterns. It will be better if they are patterns, actually. Just having, as I was saying, the distribution among districts of residents and of attendance to kindergarten, or the distribution of the income patterns, allows to carry out the validation, which means that you don't need those data for each individual, or even at sub-district level. Just having the patterns within the city allows you to validate what you have, because all of that comes from the synthetic population, data at the individual level, and the number of people involved, and the trend that you get from the model. You just need something to check against. And I'm going to conclude with the challenges. They are, for example, the usual one, having different data sets means that you have different data and incongruencies between them. There are still lingering privacy issues. As I was saying, the kindergarten one is a perfect example. I'm skipping a couple. The most important one probably is the one that I mentioned. The timing to gather all the data may be discouraging because there is not a single and common repository. And it's not like these data are private. I would say that around half of the data that we got by contacting professionals, asking if they were available, and by interaction through email. But this obviously widens the timing and also makes planning really, really challenging because you don't know with which data you will end up with. So the solutions that you want that I would like are both making patterns more available, a little bit more effort in data processing, maybe at municipality level or at institutional level, to make patterns available. Those are more than enough for the validation of a synthetic population. And also to try to integrate the data sources. There is an open data section, for example, the Tallinn website, the educational public body website for Estonia has other data, the cadastre, the land board has others. But to integrate and expand those data sources will really go a long way as well. There are a couple of applications here just to explain that this is not only for research purpose. Making this data available will make the work of professionals easier, and this kind of outputs could be used both for new models such as the agent-based one with all the results that we detailed, but also for assessment of future scenarios about land use, about some different strategies. It makes possible to carry out accessibility studies at individual level, not at land use level. And the synthetic population is also an alternative data source for traditional model building, so the traditional 4-step models and so on. So it could both integrate and substitute some of those of the data that are needed in that case. Thank you for your attention. I hope I was in the time limit. For any question, you can ask now or contact me by email. And thank you very much.
Thank you, Serio.
We are nicely on time, so as Serio already said, we can discuss now about this academic side. This time we have one academic, then practitioners presentation, then academics. So it's not half and half as usual. And as said, the whole idea of RIS sessions at the moment is to discuss about data problems, access problems, success stories, failure stories, whatever, dealing with data, whether it's real-time data or statistics or qualitative interviews or media materials, whatever data researchers are using and data that cities probably are having. So all This is the big line. But are there any specific questions to Serio at the moment, please?
Or comments related to the presentation?
Yeah, in chat or in live. And again, this whole session will be recorded, and the materials are available afterwards in the blog as links.
No questions. People are agreeing completely with you, Serio. So
that's a good sign.
It's a perfect presentation.
So Serio, what kind of sort of, how could I say, reality links you have? Are you doing your work solely in academic cocoon or circles, or are you discussing with city representatives, urban developers, practical transport planners, person like that?
I would say that it's the opposite. I am working almost exclusively with professionals and people from the municipality. Well, clearly Taltech gave us a big hand at the beginning with the travel surveys, and especially Professor Anto was really supportive, but most of the data came from municipalities and public bodies. The only issue is really about how they are distributed. The typical process was I would find a data set. There were data that were missing or a specific pattern that was not there. I had to ask by email, and more often than not, the answer was, yeah, these data are available, I can send them to you. So it's not like they are private or there were issues about sharing them. It was really about the time needed to process raw data, because then I will get raw data and I will process them, which I get. You don't post just every data set that you have. There is this intermediate step that is missing, and I think it is because agent-based model and the statistical work behind the synthetic population are kind of new. They are taking ground now in the last years. The theory goes way back, but the applications are taking on now. So probably the logic behind data sets that are shared are more related to more traditional modeling, four-step model, or the land use studies. So it's really only that, but it becomes an hurdle when you have to plan from the beginning, because you have to have at least an idea of what you will have. Do I have data about the workplaces? If you don't, there are not really many turnaround. There are some key points that you have to know from the beginning. And also the timeline becomes a little bit shaky when this is the process to obtain each single data set for each single variable.
Right.
Thank you. And I see there's a question from Alonso. So is the drawing data from the diaries to generate a given distribution that matches the census data in essence a sort of bootstrapping process, or do you modify the travel diary data in some way as well?
The first one, you don't modify the travel diaries in any way with the first drawing. It is a replication and random resampling, the step when you upscale from 4,000 people to 400,000. Then, depending on how many variables you are going to need, you can add additional variables. We followed a simplified approach based on conditional probabilities, but there are multinomial logistical regression or other possibilities to add further variables. But the key one, household sizes, gender, age, number of children, and so on, are from the original dataset.
It sounds like well, the traffic modeling is approaching also the, how could I say, not just concentrating on what's happening on the road, for example, but taking the surrounding society into account, and this is great. So I think we can
proceed.
Proceed to next one. Do we have Raimo Tengvall from Forum Virium Helsinki online.
That sounded very professional.
Yeah.
Yes. Hello. Hey, hello. I'm here. Hey, sorry. So I have some really old photo behind. No.
Yeah, it's. Don't blame yourself. We changed the link, on a fly to be able to record this session. But luckily, you were able to follow us.
I think he's talking about the
Yes.
Nexus image.
Yeah, I'm trying to get the background image away. Yeah. Okay, now you can see where I am really now, hopefully.
Koemalle vähän, kuule. 3 tunnin kuoppa.
Yes. Can you see my video as well? Yes, you can. Okay, good.
Video is not visible right now.
We can see your face.
Don't know what's happening to the video. Let's try again.
Still seeing your face.
But not as a video. Because I would like to show you where I am right now at our co-working and event space at Maria 01 Startup Campus. Okay.
Oh.
Yeah, we can see the background.
Oh, you can?
Not the Lexus. So Urban 3, yeah, we can see that.
Okay, nice. Yeah, so hello everyone. My name is Raimo Tengvall. I'm from Forum Virium Helsinki, the City of Helsinki Innovation Company, the same colleague of Matti, and the same company. And as I said, where I'm here now, it's called Urban 3, which is a co-working and event space here at Startup Campus Maria 01, and we're working here with several ecosystems from urban developments and digitalization. And what I'm going to talk to you today is this is not so much research oriented, but this might give some good ideas for research as well. Let's hope so, and also some kind of a good overview of what we are doing in several mobility projects, mostly this mobility launchpad, which I'm a project manager in. So Mobility Launchpad is a project that is funded by the European Regional Development Fund, and the idea is that it's mostly for Helsinki-Uusimaa region startup and SME companies, growth companies that want to do something in the field of smart mobility, smart urban mobility, and we've had the opportunity for them to pilot their new solutions and showcase them also here in Maria 01, as you can see in this slide from 1.5 years ago, when we had a container there outside, and we had lots of demos of different services and vehicles there. And this is part of Jätkäsaari Mobility Lab, and I think last time before Christmas you had Juho Kostiainen from Jätkäsaari Mobility Lab in this same kind of event, and he might have told you more about the datasets that are there, but you can visit mobilitylab.hel.fi and follow Mobility Lab Hel on Twitter, so you can find out more on the whole mobility lab, which is coordinated by the City of Helsinki. So it's a city coordinated test bed for smart mobility solutions, and the idea is to support piloting of solutions, and also this is more research oriented as well. So it's good that Juho has been talking about those possibilities and the data that are there. And quickly about the Mobility Lab, it's the objectives for this. It's going to be built and it already is a world-class test bed, and it's as it's the city run. So the idea is also better city for the citizens, but also for companies and researchers. It's a good environment for testing and researching new solutions for smart mobility. And here are some examples of what can be done in the whole Jätkäsaari Mobility Lab. So it's a test area that provides real life test facilities. And for example, we've had in the middle, the photo is a cargo bike that was run from Kauppakeskus Ruoholahti, so the local shopping mall, so they can get your groceries home without, even if they are even really big, and without your own car. So you can only have this kind of a cargo bike, so shared cargo bike pilot. And on the right, there's an Estonian example. I don't know if many of you have heard about this smart pedestrian crossing, which was piloted here in Helsinki, in Jätkäsaari. And we can facilitate many of those things, and also get your connections to the open data sets that are available. In this mobility launchpad project, what I'm leading, two major pilots have been done or is going to be. So first one, okay, this is wrong. So first we already had this call boats on demand electric boat pilot last summer, and it was I'll tell you about more of that soon, and then we'll have soon this cooperative ITS system, so communication between vehicles and infra. And this one is a really new thing, and somehow it's a new thing, and somehow it's a really old one, because the developments like these have been going on for 10 years already in the European level, and in many Asian countries and America. And so the huge idea is to get the infrastructure and the vehicles communicate with each other, and also the vehicles with each other, so that it enables automated driving and also safer driving for human beings, as they get some kind of informations that are not possible to get yet. Sorry about the coffee machine. As I said, we're in a co-working space in here. I don't know if you can see the photo, but this is a lively place where people live in their daily lives. Also here in the Corona times. Yeah, but in this CITS, there's two options how to do it. One is through Wi-Fi. So like a local network kind of a solution that gets to some 800 meters, but in practice not as much, so some hundreds of meters, so you can have information that's going to happen soon, or where you're going to be driving soon. So that kinds of things are already in production in Volkswagen cars, and this week and tomorrow I'll get the ID.3 electric car, and then on Thursday we'll test if our equipment really can send the messages to that car through Wi-Fi. And and another option is cellular vehicle to anything, so which is the most preferred in the Nordic countries, because maybe you don't want to build Wi-Fi network through the whole streets and highway network, and so it's better to use cellular networks that are already there, and these are tested, for example, in Nordic Way projects and many others. But we're interested now that when these Wi-Fi systems are coming up, at least in Volkswagen cars and maybe some others as well, as it almost got to a European standard, but didn't, which is a funny story. Also, that it was really almost getting to an European standard, but then it didn't. But at least some manufacturers like Volkswagen are still producing those Wi-Fi ready cars to get these CITS messages, or car to X as they say in Volkswagen. So what we've done in the project, we provide test equipment. Finnish company Vediafi is providing those. It's provided test possibility for companies or researchers, if you're interested, on how to send these messages through both of those systems through Wi-Fi or cellular networks. And the companies and researchers and the city can learn of what kind of possibilities this kind of messages can provide, and what are the limitations, because in this, for example, in this ITS G5, there's these messages, day one messages are only some 8 or 10 really high security things, so that if for example a message that if something is broken on the street or breaking quickly or something. But I can show you quickly on the Volkswagen presentation, which is a bit better on that. On what's on this. So it's in Volkswagen Golf and ID3 cars in production at the moment, and so the idea is that when we're heading to the more automated driving, this is one of those steps towards that. And as you can see, there's work zone warning, for example, if there's some street maintenance going on. And Volkswagen already got Euro NCAP Advanced Award about this, which was quite new that these kinds of awards are given in the recent years. But it's also for this V2X, and here's some kind of a roadmap. What also the Euro NCAP and is going to include in their safety rating. So Vehicle2X is going to be there. So as we know from the past, that when Euro NCAP has demanded something from manufacturer, or so that you can get some better ratings, manufacturers usually have done that. So when it's on the roadmap, also this Vehicle2X, this communication between vehicles and communication between infra and vehicles. So it can be possible that this is going to be more usual in cars in the future. And this is a bit more technical things about that. But here's the warnings that are here in the day one messages. So maybe this can tell you more of what's going on, and so that the idea is that these kinds of things can be warned to those.
We're still seeing your CITS V2X communication slide.
You don't see the Volkswagen slides?
No.
Oh, sorry. Good that you. For me, I can.
We thought you're not able to show them and you're simply speaking about them, but
we had to use our imagination, and we are not very good at that.
Sorry, we are late. Yeah.
Now we see the Volkswagen.
Okay. So there we go. So as I told about the Euro NCAP, here you can see the advanced award that Volkswagen get for this technology, and the roadmap, which really clearly says that it's for the safety ratings when this is coming up. So we can understand that some kind of a Vehicle2X is really going to happen, because it has also business potential now when it's tested in Euro NCAP. But here are the messages what I was talking about. So these are the first day one messages, and then there's day 2 and day 3 towards more automated driving. But this ones are really safety critical things that can be warned. And so the idea is that the message goes through the Wi-Fi network from another car or from a roadside unit, and it can be it is displayed to the driver, and it can also when the active cruise control ACC is on, adaptive cruise control, then the car can slow down if some of this is, for example, the end of traffic jam is coming up. Yeah, so the idea is that so that first you warn a bit and then more, and it can be seen on the dashboard. Yeah, but it's these things can be seen quite soon, how they work, because this Thursday we're testing the system. So if you're interested in this, you can contact me, and we'll have the contact details in the end of the presentation, and we can discuss more about this. And because now the real life tests can be started, and they are here until April. So now some real life tests are going up and coming up, and whatever you want to test with this, it's possible. The other thing we did, we provided in this mobility launchpad project is the pilot of call boats, on-demand electric boat, Finnish made boat, and Finnish company Mente Marine from Vaasa was behind the boat, and they were interested to pilot it somewhere in Helsinki, and then they contacted us, and then we say, hey, we have this mobility launchpad project that helps startup companies to pilot their new solutions. So we provided them with quite a lot of work. In fact, we found the location and talked with the city, and got them each other the city's demand for this kind of a boat for Vartiosaari in Itä-Helsinki, and also there was demand through participatory budgeting, so the residents demanded for this kind of a solution. And yeah, it was a really successful pilot, and so the company got it was the first pilot with passengers, and already they got more than 7,000 round trips paying customers. So it was quite a successful pilot for a first pilot. I don't know if this video can be seen, hopefully, yeah. So if you're interested in new maritime solutions, this is something to learn more and get in touch, because I don't know, the research possibilities. It is a private company that's doing the development, and they are doing it quite good. But if you have some ideas for this, for example, autonomous driving or the technologies or something like that, but also what we did have, we have some data of the usage of the boat this year, and so that kind of a some of that kind of a research is also possible, but maybe it's not huge possibilities for that, but still So the idea is that there was no real connection before this to the island, so it was like a blue ocean for that boat to get, and already got so many more than 7,000 paying customers, passengers already. But yeah, but the future developments of the Mente Marine company that's doing coal boats, they are doing bigger boat in this is 3D model is the bigger boat, and also the one that was in traffic is going to be next year as well, somewhere, hopefully. But the bigger one is also under development, and the idea is that it's possible to get some other many pickup points. Now it was from A to B, so it could be from A to B or C or D. And also autonomous driving is on their list, and the software is already capable of autonomous driving, but it all still had a local unit as well, like a joystick where it was driven mostly now. But the autonomous driving is there on the software, and they are developing it. And so the first step is, of course, not fully autonomous but remote, so that one captain can be driving many boats from in the same area, which also makes it more efficient. Other project where I was in was called New Solutions in City Logistics. It already ended, but there's a couple of things that might have some good research possibilities as well. One is okay. It started from open logistics maps, so we gathered data. We first for Virmo Helsinki, we made this tool for gathering the data of entrances. So now the address system is so that there's the house number, which is also like the number of from the whole area, as they said tontti in Finnish. So it would be, but the need is really huge for more accurate data for logistics and for many other purposes as well. So to have accurate data of entrances of houses, and one house can be so many entrances with different possibilities. So they have steps or they are locked or not, and they are open or private or for delivery purposes only. So we gathered the data mostly by teenage summer workers, which was a really good experiment. It was quite good data, in fact, that they got, and the teenagers are really good in working with their smartphones. So getting them to work with their smartphones and walking in the city and get these informations, it was quite good. And the data was exported to OpenStreetMap, so it's there. So OpenStreetMap, okay, many services use OpenStreetMap, and now it's there's much more rich data of these entrances in OpenStreetMap for everyone to use. And we also made with Mistmap and Sproutverse, those companies, we made a route optimization tool, so like a last meter for last meter logistics and or last meter navigation, how to get to the right entrance based on this open logistics map data. And it was tested by logistic company A to B, and there was some potential seen. So all this compared, we saw, and also the city of Helsinki saw a possibility for the next project, accessibility data for logistics. So it continues this work. So we can contact mine and Matti's colleague Sami Sahala for this entrance data things, because this project has just started and it's continuing what we've done in this city logistics project. And the last but not least, we had an autonomous courier pilot called Home on Demand in Kalasatama area and here in Helsinki. And there's a skyscraper called Redi Majakka residential building with almost 300 apartments and 34, 35 stories. So so we made this pilot with companies Dimalog and design studio Muoto Hiomo, and using Omron robot, and with huge partners like the construction company SRV and Kone, the elevator company, of course the local supermarket and the building. And here's a video of how that worked, or some quick one of that.
Serving customers is my duty. I'm the new delivery bot of Freddy. I'm always a bit nervous before entering the lift. Excuse me, this is my floor. Thank you for ordering. It was nice to serve you. Until next time.
As you can see, the amount of logos, so it was like a huge cooperation, and that's something we are good at in Forum Video, this kind of huge cooperations with multi-stakeholder pilots. Yeah, so what we did, 4-week pilot, we got 86 deliveries, so real customers that ordered their meals from the supermarket, so real paying customers, and 61 different apartments. So all of the almost 300 apartments were mapped for the robot, so it could deliver it to any apartment in the building. But 61 ordered during these 4 weeks. Yeah, and what was really good and really nice was that all deliveries were carried all the way to the entrances. So it worked that way really good, and most of the journeys didn't have any even minor problems. So this is quite ready for some because the robot, Omron robot, the platform there that has been used in like industrial areas for many years or almost decades already, and now we took it to this kind of urban open environment, and it was nice to see that it worked there so good as well. But the examples of real life and or commercial usage like this are really few in the world yet, even though the technology is quite ready. So it might now need some more tasks for the robot, because the robot can work 24/7 for almost the same price. So if it could have lots of different things to do during the whole 24 hours of a day, so it might be really close to the really commercial usage of these kinds of robots now. And now it's interesting, and we are interested to see that if things can be done towards that direction, or some projects can be started for real business potential, and so like economical research or business research or technical research of the multiple purpose solutions, this could be done, would be interesting at this point. Thank you, and hopefully some questions. I don't know if this answered or this might be a bit different than you expected, but there's lots of things that we've been done, and how can we found the research points here. It's it's interesting to talk about that.
Thank you, Raimo. I don't see any questions in the chat. Please feel free to type in or open your mic and present it verbally if you have any questions or comments for this. On my behalf, and of course I'm biased because I'm your colleague at Forum Video, but this was a really good sampler plate of the type of pilots that we have been involved. And again, I hope this for the research community gives some inspiration of how to build these type of pilots in an agile way and a low effort way, so that we don't have to plan for a really long time and make really big, complex project plans, but the pilots themselves can be triggered from an individual company or an idea, and they can be tested quite easily. And then hopefully the companies or innovators who are behind the idea, then they will be taking it forward on their own. Any questions or comments from the audience?
While you are thinking your research collaboration questions, I'm making one perhaps quite broad thing. We all know that Raimo has also a very long history in not car industry, but you know, consumer cars very well, and you follow the development of that industry, and we know from history that car industry has been very rapid to integrate whatever interesting device into cars. 1920s, 30s it was a clock, then in 1990s it was the radio set and all that, and then navigators. How do you feel?
Air conditioning.
Yeah. How do you feel this vehicle to X thing that you mentioned it in this Volkswagen slides? Is the world going to change? Is the car industry still able to own the data that they are gathering with all these sensors and functionalities that these the new cars are able to do? How do you feel? Is open data culture coming to car industry at all?
When forced, probably when forced in a good way. Seems that not very quickly, as we've seen. There are some interesting things happening, maybe something bubbling under. For example, we are involved in a project called Smash Hit, which is a My Data project. It has also Volkswagen in that project. Volkswagen IT research department from Hannover. They're in the project partner, and they are following what's happening in this kind of My Data or open data, both of those questions, but seems not very quick on that. Of course, this vehicle to vehicle data. So the idea is that it's like it's not standardized yet, but as in like a real European standard, but it is standardized data. So you send the data that, hey, the car is like braking hardly or something like that. That kinds of information, when it's security critical, they can send it to others, and yeah, but it's quite baby steps for that more open data, and in this case, this CITS or vehicle to X things, it's been that it's been mostly like a European level or European level cooperation of like transport, the governments or or transport officials to get that kinds of things, and the car industry has been following on that purpose, so that the cars can be better when they get data from elsewhere. So that's also the idea that, hey, if the cars can get data from elsewhere, why not? But if you had to, but when the car's data to open, that is a good and more tricky question.
Well, I think we will see much more and know much more about this in the just few next years, because there's a big revolution going on in automotive industry and in transportation in general, and we will see if cars will turn into platforms rather than kind of controlled technological solutions.
Yeah, and also if I can add on, it's so that it depends on what kind of information, because of course cars are for those kinds of apps that cars want to be platforms for people's living. So the apps that people use elsewhere in their life as well, so they are more and more integrated to cars. But the car's own technological information, getting that open, that's a more tricky part. But of course, the destination of your mobile phone is something that, of course, it can be, and also things like Google Android Auto or Apple CarPlay are a good examples of that. How the cars and the mobile phones and ICT things are getting together.
Yeah, we're living interesting times. The Finnish rap singer from 1990s, Nikke T, said, jos haluat saada, on pakko antaa. So if you want to get something, you have to give something, and I think car industry has to take this account when there are more and more collaboration, even in normal everyday traffic situations. All right, we are nicely late in the schedule. Hopefully, Iisakki is still with us, waiting for his turn. This mobility launchpad was taken before, because it's sort of launchpad and Iisakki's work is sort of part of that. So it was the Raimo's presentation was sort of very general. Sort of introduction to thematics that Iisakki is going to present more precisely, or one research project inside of this.
So thank you once more, Raimo, and we're moving on to Iisakki's presentation.
That's what I was saying.
You did not thank Raimo.
Oh yeah, true. I wasn't polite.
It's a very polite thing to do, especially since we've been requesting him to participate so many times, and he finally gave in.
All right.
Okay. Can you hear me and see the slides?
Yes.
Yes.
And yes.
Okay. Great. So as Raimo already explained what is this Mobility Lab Helsinki and the Jätkäsaari Mobility Lab project. So this smart junction project is part of that bigger framework, and we are working closely with the city of Helsinki and the port of Helsinki, and also with the private company who is providing the technical side of this. So and this is something that we also proposed. The connection to the Finnish Twins is that we proposed something similar to the Smart Cities Challenge last year. It wasn't successful, but perhaps there is some ways later to find out if it's possible to cooperate with the city of Tallinn too. But now on we are working with the city of Helsinki, and here is an here is an overview of of the system. So what we are doing at the moment in this Jätkäsaari region is that we are setting up radars and cameras and connection to the signal controllers, and we collect that data into a model that is representing the traffic situation, and we provide also open data for other partners, and then we analyze that data in real time. And then in the second phase, we are going to use that data for optimizing the traffic management and especially the traffic signal control. And later on, there are also ideas on using the emission data and modeling the air quality and so on, and also cooperate with the connected and automated vehicles and perhaps giving alerts to pedestrians and bikers if necessary and so on. But right now we are in this phase 1 in setting up the sensor network, and we are continuing with that. The technical platform is needed to collect the data and manage the data and have a communication between various partners of the system. And so there is a message exchange system called NATS, and all messages are JSON. And then we have some open APIs for others to use the data based on REST protocol and WebSocket protocols. And that's shortly how is the technical framework, which is provided by this company Convex Limited. And this is the area where we are setting these sensors. It's the main corridor in and out from the harbor to the motorway here, and we put one sensor station in each approach of the junction, so that there is camera and radar pointing towards each approach, and then there is a box that is collecting the data and doing some edge processing if it's necessary, and sending that data to a server for further processing. Also, emission sensors we might add here at some point, but at the moment we use these. And there is also a connection to the signal controller to get the traffic signal status data and detector status data. So the camera data looks like this. This is a sample. This is not real time, but it's a sample of the real time data. And we are aiming to use the camera mainly for detecting accurately the type of vehicles. Is it a passenger car or truck or bicycle or something else? Because that's what the radar is not so good at. And then we have the radar data that is here. The radar is situated in front of the Clarion Hotel, the first radar, and it is measuring more accurately the movements of the vehicle, their position and direction, but not so well the vehicle type. There is still a lot of noise in the data, but we need to do further processing in improving the accuracy. So this data is available by request and for open data for various purposes to be used. And then what we are focusing here is to combine that radar and camera and signal control data with a real-time simulation model. That is, the point of that is to model exactly what's going on in this area, what is the traffic situation, and that can be used as an input for the traffic management and traffic signal control. So we call this approach a digital twin, which is familiar from the construction engineering and civil engineering, but we call this real-time digital twin, so that we have a second-by-second model of what is the situation of the traffic, what is the speed and position and direction of each vehicle at any point of time. The other way of using of course this data from the field is that we just make scenario simulations based on the real data, for example, coming from the harbor and other directions, and then we can test different control alternatives. And so in that case, the system is not operational in terms of connected to the signal control, but it is for evaluating different alternatives. So there are at least these two possibilities, and maybe some others we are thinking further. So here is an example of this, what we call real-time digital twin. So the traffic signal status, you can see here these lines. It's coming directly from the field in almost real time, and also the vehicles coming from this approach is coming from the real data from the radar and also detector data can be used. But since we have, at the moment, we have only one radar, so the other directions are still just random data, but I think within January we will have these all directions here covered, so that we will have the accurate traffic from all directions. And after we have set this one intersection, then we will expand to the other seven intersections in this corridor. Okay, and then we aim to while collecting all this data and integrating it with the traffic simulation, then we collect a lot of measures of performance that we can store in the database, and we can have the different type of metrics of performance and time series and analysis tools for the city planners and other interested parties. Also animation of the traffic situations, the actual situation of the scenarios, and users able to control the operations, giving policy objectives and running simulations if needed. And then the control algorithms, they can be basically anything. We are in a process of developing a new type of control algorithms, especially for the track platoons. That is the problem in this area. But also we are thinking we are preparing of using various sorts of artificial intelligence or deep learning neural networks in traffic signal control. Okay, so that was more like the technical part of this, and then we have this research that is mainly responsible of the university and our unit, and here we will then focus on optimization of the traffic management and traffic signal control. But this also we need to have the technical platform ready before we can fully focus on this. But this picture is to kind of illustrate the different challenges in both Helsinki and most likely also in Tallinn, that we have a certain cycle of traffic signals, typically like 90 seconds or something, and these are surface junctions, which means that the capacity can be quite limited, and then we get a very dense platoons of trucks every 1 hour or 2 hours or so, and we have also public transport priorities. And in Jätkäsaari region, we have also heavy pedestrian and bicycle flows. So this is a very challenging environment, and we have different frequency components, like this frequency of the signals, frequency of public transport, frequency of the ferries coming to the harbor. So it's a challenging optimization. I will not go into the details of the optimization, but I give some examples some ideas that we are working on at the moment. One is the smart priorities that compared to the traditional priorities, this usually applies to public transport only, and given every time you request it, and assuming that there is a large vehicle with a lot of passengers. But the smart priorities depends on various factors, like what is the overall traffic situation, and what is the impact of the proposed priority to other traffic. Is the vehicle being late or ahead of its schedule? What is the number of passengers, and so. And also we can apply this not only for single vehicles, but for dense platoons of vehicles, the same ideas. And yeah, so we can apply this for moving platoons, and we will present the results of that then later on. Then the other approach by PhD candidate Roosbek Mohammadi is the user-based signal timing optimization. So instead of the vehicle having the input of vehicle flows and amount of vehicles in the queues, we measure or estimate the number of people either in the vehicle or in the pedestrian zone or biking or in a public transport. So this kind of paradigm needs the connected capabilities to get the precise number of persons in a car or persons in a public transport vehicle and so on. But already now we should be able to measure the pedestrian flows waiting for the traffic signals and also the bicycles waiting for the green lights. So we can adopt some of this concept already before we have fully connected environments. And Then one approach that is research of PhD candidate Tuomas Toivio. He is working on policy-based optimization. So that the idea is that the city can define its own policies regarding the specific area and what kind of policy they prefer, whether they want to optimize the fluency of the traffic or the environmental aspect like the emissions, and so that the system can be optimized in different ways. So we have different control loops here. The first loop is the usual the traffic, or actual traffic or simulated traffic, and then the signal controller, which are exchanging the sensor data and the control decisions. Then there is this other layer that is the optimization loop that is optimizing the parameters of the signal controller. So this is a slower, this is a faster loop is this first one, and this is a bit slower and adaptive, and it is changing the parameters. And then the third level is the policy tuning loop that is getting the performance results, and you can define the policies to this optimization loop. And so here you can define then if you prefer to optimize based on fluency only or emissions only, or something between. So here is an example of the. Here is step one is the single criteria optimization, so that the level of service is in practice that's the average delay in this junction, and we can see that in this case we compared the usual the gap seeking algorithm with fuzzy control, first without optimization and then with optimization, and we get kind of the significant improvement there in terms of delays. And then well, let me take back. Then we had a similar optimization in terms of, or from environmental perspective, which means that we optimize the signal control based on vehicle stops, so minimizing the stops, which is has a strong correlation with the emissions. And then the final step is that with this first optimization, we get the optimal or what is possible to achieve by single criteria, and then the user can give what is kind of still a tolerated value for delays and stops, and then the policy tuning is operating within this boundary box, and user can then choose a policy that he or she prefers. And so we are now focusing on traffic signal control, but we also want to keep in mind that in this area it's also possible to do route guidance, because while trucks can only use this main route, for passenger cars there is another alternative route, and then depending on how congested this main route is, passenger cars can be guided to the alternative route, and that is a future possibility that we can focus on later. And already now there is information about the ferry arrivals, that we get some number of the expected vehicle counts from the ferry that arrives, and it takes some time for these vehicles to achieve the first intersection here in this area. So the idea is that we can then prepare this signal control in advance to handle better the heavy traffic of especially truck platoons coming from here. That's very heavy traffic, but it's kind of a burst that lasts maybe 30 minutes or 45 minutes and something like that, and then it's back to the normal, and that happens maybe 8 or 12 times per day. But that's the idea in the future. And also we want to keep in mind this connected and automated vehicles, because also especially when we have a mixed traffic of automated and manual driving and anything between, it is getting more and more important that there is a very accurate estimation of what is the traffic state, and also the traffic signals can be transferred to the vehicles directly in addition to these physical traffic signals. There can be new ways of controlling the traffic by directly adjusting the speed or lane of the vehicle and making them, kind of forcing them to form platoons that are then coming different times to the junction, and that improves the performance. And various safety alerts can be given based on that we know the speed and position of each vehicle, and then pedestrians and bikers especially can be warned if there is, or a driver can give a warning that there is a pedestrian behind a wall or behind another vehicle or something, and that kind of possibilities. Kind of extended electric horizons, if you like. Okay, so I think that's what I had in mind. So we go ahead with this project and continue with the installation, and we expect to have more results soon this spring, and then we can tell more about how this project is progressing. And if you want further information, you can contact me or other people here in this list, and if you are more into the technical questions regarding the open data, then you can contact these persons from the Convex Limited and get more information of the technical side. Okay, thank you.
Thank you.
Thank you, Iisakki. So are there any questions from the audience to Iisakki or to Raimo or to Serio? Starting maybe with the latest presentations, so to Iisakki.
Hi, it's Kylle here from Estonia.
Hi.
So, do you know any examples from the world where this smart junction, at least in some aspects, has been implemented or tried out?
Maybe not exactly the same way. There are like real-time simulation has been applied, but it's more like in a network level and maybe in not that detailed level that we do more focusing on traffic management and optimization of traffic signals, but it is not very widely used at my impression at the moment. So I think it's still not recognized the full potential of this approach. But we have some tests already in Finland with single intersections that we have used this same concept without the radars, but based on loop detectors only, and that was kind of working, but the precision of modeling of traffic situations was not so accurate as with the radars. So now that radars are available and cameras and video processing is improved, we have better chances in having exactly the traffic situation right, and then based optimization on that. But one test we did already couple of years ago, 2017 in US in San Jose, and there we installed in one very big junction. We installed the radars and this real-time simulation, and we collected the data and the metrics out of that system. So we have done experiments. So this is not the first time, and also with the Helsinki. Actually, in this Ruoholahti area, we also, next to the Jätkäsaari, we have done real-time simulation experiments some years ago. But then also the technology was a little bit not quite good enough. But now it seems that we have all the pieces that is needed for actually making it fully working and getting the sufficient accuracy and performance and technical soundness.
Thanks. I was just about to mention this. I think it was the traffic innovation zone in San Jose that has been quite active in testing, but then by what I've understood, there are quite a lot of differences in the regulations related to experimentation in traffic between, for example, North America and Europe. So what can you say something about the differences between, for example, what we are allowed to do here in Finland in Jätkäsaari or Ruoholahti versus what they have done in the traffic innovation zone?
Yeah, well, there was a lot of some kind of difficulties in San Jose, like for example, getting the power supply or various technical things. But yeah, it was doable, and also probably the processes of supporting this kind of piloting was not so ready at that time, but so there was smaller hiccups that slowed it down, but then we managed to go through them. But I think now that the thing that we have in Jätkäsaari is more evolved, because there is already the kind of idea that okay, we are going to put these sensors, and there's an organization and a project that supports this kind of activities, and you have the people to talk with, and you can apply the funding, and you can. So I think it has evolved from that, even now in this couple of years, into this kind of more established living lab environment where there is the dedicated area, and there is the support from the administration, and there is an organization that is willing to support you, and also we managed to get funding for the hardware to be installed, and then Henry Ford Foundation is supporting the research side, so that is very much helping. But I cannot say for sure that if it's in general, if things are better in Europe or Finland in general, there might be different cases and different areas where you can try things, and maybe different policies, but probably both sides of the Atlantic there is now recognized that this kind of living lab environment are needed to pilot this kind of new solutions.
Thank you. And it is almost 2 o'clock, so it's time to start wrapping up. Thank you, Iisakki, for a really good presentation, and again, we hope that there will be people who will be also eager to follow through these presentations online once we post them on our YouTube channel. To all of the research community that's still here, there's a short announcement on behalf of the Finesse Twins project. So on February 2nd, so far it's a plan, but there will be kickoff for the affiliation model of the Finesse Twins, meaning that we are describing the new policy for affiliating all of your publications and research work to the Finesse Twins project. So that model will be presented and officially started on February 2nd. There will be an invitation to all researchers who are part of the project, but that's in the afternoon. Let me check the exact time. So it's from 12:30 to 2 o'clock on February 2nd. So just a heads up. And thank you for all presenters, for Claudio, for introducing your research stream, and then for Serio, Raimo, and Iisakki for your presentations. Kalle?
Yeah, I say the same. So the affiliation model is a very crucial thing. Ralph is running it almost full time. So far, it has been simply to sign a paper and send a message that I'm in. But thinking of the center of excellence, it's very important, and it deals with your future salaries, I'd say, in a short and brutal way. So follow that process. All right, time is up. So are we.
Thank you for sticking up until 2 o'clock, and hope to see you all in the next session.
Next session, follow the RIS blog. There's the information dealing with the next one.